Glaciers are an important freshwater resource for more than a billion people and are an essential part of tourism and cultures around the world. As these glaciers continue to respond to climate change, societies must adapt to changes in water availability, natural hazards, and sea level rise, of which glaciers are a primary contributor. In our recent study published in Science in January of 2023, we've modeled the evolution of more than 200,000 glaciers globally, excluding the ice sheets, to determine the differences in projected glacier mass loss, glacier contribution to sea level rise, and the number of glaciers that will be lost completely between now and the end of the century for different climate change scenarios. This enables us to understand the importance of climate change mitigation and what we can expect as of now if we are able to limit the global mean temperature increase relative to pre-industrial levels to plus 1.5 or 2 degrees Celsius compared to higher temperature change scenarios of plus 3 or 4 degrees. We project that between 2015 and 2100, glaciers will lose approximately 26% of their mass for the 1.5 degree temperature change scenario and upwards of 41% for the plus 4 degrees scenario. This would result in approximately 49 to 83% of all the glaciers globally being lost, a higher number than the relative mass loss because the majority of lost glaciers are small. Equally alarming is we project glaciers will contribute an additional 90 to 154 millimeters to sea level rise. Given that glacier mass loss is linearly related to temperature increase, reductions in temperature increase will directly reduce mass loss and glaciers' contributions to sea level rise. Based on climate pledges from COP26, the global mean temperature is projected to increase by 2.7 degrees Celsius, considerably above the 2-degree threshold from the Paris Agreement. Here we show the regional variations in relative mass remaining for a 2.7 degree scenario, with red colors showing areas that experience considerable mass loss, and black circles showing completely deglaciated areas. We thus project that large sections of Western Canada, the contiguous United States, Central Europe, and the Caucasus and Middle East will experience widespread deglaciation, and overall glaciers will contribute an additional 115 millimeters to sea level rise. The greatest regional contributor to sea level rise in our study is Alaska, which also includes some glaciers on its border in northwest Canada. Alaska is unique in that it is heavily glaciated and is also experiencing some of the highest rates of glacier mass loss of any region in the world, losing approximately 9/10 of a meter of ice per year over the last 2 decades. Depending on the temperature change scenario, we project that the rate of Alaskan glaciers' contribution to sea level rise will peak between 2035 and 2060 and will subsequently decrease over the rest of the century because there is simply not enough ice for Alaska to continue losing mass at these high rates. The other primary contributors to sea level rise are glaciers in Arctic Canada and those in Greenland and Antarctica that are not connected to the ice sheets. The maritime climate of these regions make them highly sensitive to increases in temperature. In regions such as Arctic Canada, regional temperatures will increase by an additional 2 to 3 degrees compared to the global mean due to Arctic amplification. Limiting the global mean temperature increase to below 2 degrees is critical in these regions to prevent the rate of mass loss and thus the glacier's contribution to sea level rise from steadily increasing over the rest of the century. The rapid increase in glacier mass loss and corresponding contributions to sea level rise for global mean temperature increases beyond 1.5 degrees stresses the urgency of establishing more ambitious climate pledges to minimize future impacts and preserve the glaciers in these mountainous regions.